Okay, so in the last class, I was talking about data models. And so the relational model, which is what we will be doing in this class, is very structured. Um, so then there's XML and not only SQL, which are both semi-structured. And then there are text documents that are completely unstructured. So the real difference, if you had to look at it, is relational databases are schema on read, or schema, by the way, means database design. So relational is schema on write. I said it the other way around, because when you write, the relational has a very predefined, well-defined structure. The file system, the design, it has to be designed before you can even start entering any data. So it's a schema on write. On the other hand, when you have something that's completely unstructured or semi-structured, it's the application programmer, when you are reading the data, that is the time you kind of make the design. So it's a schema on read. And because of this difference, that is the reason that relational databases, their retrieval programs are all very simple. Because at retrieval, you don't have to, the design is already fixed, you just have to read the data off. On the other hand, when you deal with text documents and things like that, the programs that retrieve from these other kind of databases are a lot more complicated. So if there are no questions, I'm going to continue with today's lecture. So today I'll talk about the steps for building and using a relational database. So so the first step for relational database is always, designing the schema. So that, which is the database design itself, is the most important part. So that's step number one. So once you design it on paper, and we will be doing that in class when we do ER diagrams, the next step is to create the schema. So you're going to create the schema, and you're going to use DDL. So that stands for Data Definition Language. So the DDL itself is a part of SQL, which is the language you use to retrieve data from the database. So for example, the way you create a database is, this is the, in SQL, this is the language you use to create a database, So university is a very common example. So let's say we're creating the database university. So in SQL, if you write create database university, it creates a database called university. Then once you have a database university, right now it's empty. So you have to create files to put in there, or what we call tables. So that's the next thing you do. So once you create it, you then so let's say we are creating a table called student. And then you have the student's name. Then you have the student's identification ID. So So I'm defining it to be integer, and I'll talk about this thing not null, but just by the language itself, you can understand that that means that the student ID, you can never leave it blank. Every student must have an ID. That's what not null means. And then let's say we write down the GPA. And then whether they are a freshman, or junior, or senior, and let's use a number for that. So this is the language in SQL that you use to create a table. So that's step number 2, is to create the schema, and that's how you do that. And then once you create the schema, the next step is to load the schema with data. And often when we have, like, for example, let's say that we create a database for UNH, already we have lots of data. So you got to load the data in, and often the data may be in files. So you can just load it from the files. So that's step number 3. So the SQL command to do that is insert into, and then you give the file name student, and then you insert the following values, and then so Smith, his student ID is 17. He has a GPA of 3.8, and he is a freshman. Let's say Brown has a GPA, has a student ID of 100, has a GPA of 3.2, and he's a sophomore, and so on. So that's the third step, is you load the database with initial values. And once you do that, then you can query and do updates on the database. And this step is, once you have that done, this step is the one that you will constantly keep repeating. So the first 3 steps are usually a one-time process. So that's one of the things about relational database, is that you have to spend some time designing it. And because once you create the database, it is not easy to go back and change the database. Because those steps, it was designed in such a manner, yes, you can do it, but let's say that don't completely change the design of the database. Once you've started, you might as well restart the new one, because that's one of the things about relational, is that the design must be well set. So this query and updates you do with the part of SQL that's called DML, that is a data manipulation language. So both DDL, which is a data definition language, and DML are both, parts of SQL. So, and one of the things I mentioned yesterday was that unlike Java and C, which are procedural languages, SQL is a declarative language. So you just have to say what you want, what should happen. Just like we talk in English, I say, okay, I want to see the list of students who have a GPA, say, greater than 3.4. That's SQL. You just have to say what you want. But if I had to do that in, say, C, I would have to write, open the file, then I have to say for I going for so-and-so, go down each file, check, so you have to write the entire procedure down. So that's the great thing about SQL, is that it's declarative, it's not procedural. So for example, this I would, if the query that I just mentioned, I would write it in this form. I'll say select name GPA from student where GPA is greater than 3.4. So it's just like what you would say in English. You are going to write down exactly, and that's what SQL will do. And so if you give this kind of query, the output from SQL will be a table again. So that's the thing. The output would be in this form. You'd get name, GPA, and then you're going to get an output would be in table form. So let's say Mary has a GPA of 3.5 and Sam has a GPA of 3.8. So it'll output all the students with the GPA, but what you have to look at is that the output is also a table. And so that's the one of the nicest things about relational databases is that you can, because it's closed under, of all operations, since the outputs are all tables, these tables could also be inputs to other queries. So the output, so the possibilities are much larger now that you know that you can generate an output of a query and then use that output as an input for another query. So that's the, the takeaway from this is that the result of a query is a table, so it's closed under this operation. So, so this actually brings us to, like what is SQL really? Because really the first half of this class is really going to be all about SQL, and a lot of the second half is also going to be that. So SQL is based on the set theory. Also relational algebra and relational calculus. So I do, so that's part of the thing is that even if you haven't, you don't have any, if you have knowledge of set theory, that would be really good. But even if you have, so you must have done sets, if not in college, at least in high school. So because it's entirely based on set theory, SQL, you'll find it a lot easier to understand it if you know set theory. And it's based on relational algebra and relational calculus. And that sounds a lot more scarier than it is. It's all actually relatively easy. So I'm going to start before I do SQL, I will do relational algebra first, because you'll find SQL a lot easier if you understand what it's based on. Relational calculus, on the other hand, I'm going to, later on, we'll get to really tough queries. And at that point, when we do tough SQL queries, at that point, I will explain a queries by using relational calculus. So I'm not going to do relational calculus ahead of time, but I'll do relational algebra ahead of time. Do you, any questions? If you have, just jump in. And if you can't hear, if the audio is poor or something, I'll try to speak up. Okay, so before I do, I just want to go over some examples. And one of the things I mentioned is that I will put up PowerPoint slides of most of the chapters. So this is just taken from the PowerPoint slide. So this is an example. University is the most common example in textbooks. So in a university, so this is the database, the university database. Um, so these are all the tables in the database. This database has 5 tables: student, course, section, grade report, and prerequisite. Um, so, so if you look at a table, let's say the student table, there are, it shows student number. So, so this is the table name. And then each table name, each table has 4 columns. So these are the columns. So columns are called attributes, and I will go over some of that stuff. So, and then this defines the format. So name is a string with alphabetical characters. And then this is an instance of the database. So it shows the values in course, in section. And one of the things I mentioned in the first lecture was that in a database, relational database, all the tables are related. There, you will, I mean, if you look at all the tables, you will find if you pick any 2 tables, there is some relationship between them. So, for example, if you look at course and section, the course number, that's the column that's related in these 2 tables. So for example, if you gave a query such as, suppose you asked a query, who teaches who teaches data structures? So if you ask this query, who teaches data structures, you cannot answer this query by just looking at one table. Because, for example, if I looked at this table, I don't have data structures in here. And if I look into this table, I do have data structures, but I don't have the name of the instructor. So in order to answer this query, you would have to look at 2 tables. So you would look down here and say, okay, data structures is here, and it's stored, and the number is CS3320. So then you go down into this table and look who has that. I guess there's only one person. So, and Nuth teaches. So, and then you find, okay, so this is the answer. I don't think there's anyone else, right? Yes. So that's one of the things about relational databases is that sometimes to answer a query, in fact, often to answer a query, you have to connect or join multiple tables. So, okay, so then these are the prerequisites and all the other tables. And then this is just some of the metadata. So this is how, when you list the database structure, this is what will come out. It shows you all the relations, the number of columns, and then the column name, the data type, and then where it belongs. So, so I'll be putting up a lab at some point, and you will be able to see all this. So another thing with relational database is that you can, so you can create a view of the database. And by view, remember I mentioned that when you give a query to the database, the output from a query is also a table. So a view is is a table. It's a, like, you can think of a view as a virtual table. So what that means is that when you write a query, it creates an output, and the output of the query is also a table, and that table is called a view, and you can use that view to generate other queries. So that's what a view is. So and this is just an overview. You're going to be doing all this stuff later anyway. So does anyone have questions up to this point? Do you understand the material so far? Okay, so then let's look at like who are the people who use the database. So we have so of course you have the users, the end users of the database. So those are the data that so that's the largest population. For example, Mycosis is a database. Pretty much anything that you see, like airline reservation, those are all databases. So we are all users of Mycosis. So, it's a large population. So all we do is, generate queries. And of course, we are doing all these queries through the uh, web pages. But but we are really whenever you click anything on the mycosis, what's happening underneath the clicking is that there is a SQL query that's getting generated, and that SQL query is accessing the database. So that's the database users. And then we have the application programmers. Um, so those are all just that would be you and me when we work in a corporation, when we work in a company. Most probably we will be writing programs for the database. So we will be the application programmers. And then you have the database administrator. Database administrators. So application programmers, even though we write programs, um, we have limited access. So what I mean is that you don't have permissions to, for example, if you're an application programmer, most probably you will not have permission to change the structure of the database or the design of the database. You might not have permission to build indexes and things like that. So administrators are the people on the back end who you know do things that they have all permissions. They may be changing the structure, they may be building indexes, they might be they restricting the permissions different application users can have. So database administrators, they pretty much can do anything on the back end. They have permission to do all kinds of stuff. They are the people also to some degree who determine on the back end storage decisions, like how you know what kind of indexes should be built and things like that. So the database administrators have a lot more permissions than an application programmer. And then finally, there is also the database designer. So I kind of did it backwards. So they are the people who design the database before design the structure and things like that. So I would say that these are the 4 types of users. And in this class, you're going to be learning what commands that from all these different people will use on the database. Um, so I just want to do, when I spoke about database users and my courses, like I mentioned, you as a user are not aware of it, but a lot of stuff when you click on a web page and things like that, you are generating SQL queries on the back end. So from a high level viewpoint, a diagram could look like, so your web application. So that's the user, and maybe the user. So the user is using these web applications through web pages. So at this end, there's a database. And if it's say a relational model database, and there are SQL queries. So whatever you're clicking on, they generate SQL queries that go to the database and retrieve stuff off the database. So a lot of times even when you use things like XML and stuff like that, on the front end, it may be an XML kind of database, but on the back end, it'll be a relational model. So a lot of the databases that are currently in use are relational model, even though NoSQL and all are getting very popular on the back end, a lot of the databases are the relational model. So this is it about the introduction. Does anyone have any questions on the material I've covered so far? So then I'm going to move on to, so that was chapter 1. So I'm going to move on to chapter 5.1. It's some of you have, I know the textbooks are quite expensive. The old model is also, there isn't that much difference between the old model and the new model. So it's chapter 5.1 on the new edition, but on the old edition is chapter 3.1. So if you have the old edition, that's fine. So the kind of maps, I'll write it down out here in case some of you have the old edition. It just maps exactly to chapter 3.1 in the old edition. So this one just talks about some of the, the basics of the relational model. So I'm going to that you need to know for doing relational algebra. So the relational model was actually started by Ted Cord, or let's put it this way, it was designed, or it's a creation of Ted Cord. He was at IBM, and this was done in 1970, and he wrote a paper that was published in the IBM journal, where he wrote out this design about the relational model. And this one paper started a several billion-dollar industry. So that is a really big achievement or contribution. So since the relational model so right now it started in 1970 and it's been going strong. It is still the strongest database that is around, and that's a long time. I mean, that is a very long time for any system to last. So there were times, even that there were people thought there would be other models that would replace the relational model. So for example, when I was a student, I remember that there was a lot of excitement about object-oriented databases, and there was a lot of we thought that object-oriented databases were going to replace relational databases, but that did not happen. The relational databases are still around, while object-oriented has pretty much faded away. I'm sure none of you will study about object-oriented databases, something that we had to do because we thought that was going to be a big thing. Then there were other things. Then XML was there was a big lot of excitement. And while XML is still around, it hasn't replaced relational databases. What's happened a lot of times is that XML gets built on top of relational, because XML is very convenient for doing web applications and web pages, but it still hasn't replaced relational databases. And now we have not only SQL, and no SQL does not mean that it's not SQL. It just means that it's not only SQL. A lot of those databases still have relational on the back end. So relational has been around a long time. So in case you're wondering, is there any point in studying relational databases? Should we go on to text documents or no SQL? I just want to say, as of now, I don't know about tomorrow, racial databases is still very, very strong. And even if you have a no SQL, not only SQL system, there will be relational stuff on the back end or on the front end. They will be doing some kind of relational. So it's a really good model. And part of the reason that the relational model has lasted so long is that it's built on a very strong math foundation. Um, so and you will see that when you do, it's entirely built on relational algebra and relational calculus. So it has a very strong foundation, which a lot of the newer systems don't have. And that's why they flounder, which is why a lot of the queries and all that are generated there are so complicated. So yeah, so I would say, yes, it's really worthwhile doing relational databases right now because it's still around as of now. I can't really talk about what will happen in the future, but relational is still going strong. So it started a several billion-dollar industry, and like I mentioned before, the unit is the table or a relation. It could be called either, and it's called relational because the unit was a relation, and these tables are all interconnected. That's important. And to the theoretical basis is relational algebra and calculus and relational calculus. So now I want to just talk about the table itself. So again, so let's look at the student table. So the name student is the table name. And so let's say we have and so let's say we have 4 columns. Okay, so you have Jim, and I'm going to write down value out here, and then I say, and then so on. Okay, so this is what a typical table would look like. So the first one out here, these are called the attribute names. Okay, so these are the attributes, by the way. They're called attributes. Those are the columns. So columns are typically, they're called attributes. So this is the attribute name. And then every row, so each row is called a tuple. So So they're called tuples. So that's the notation that is used. And there's a very special value called the null value, and I'll talk about that later today. So a database consists of a set of tables. And so that's so there's a set of tables. So that's why, so each of these tables is really called a set. And that's where I said, it's based on set theory. The schema, which is a design, is the structured description of the tables. And then the instance of a database. So I do want you to, because this is, these are just terminology, and you may be sitting there and thinking, oh, this is no big deal. But you need to remember these, because when someone talks about the instance of a database, that is just the actual contents of the table. So the schema of a database does not change. It's pretty much set. You would not want to keep changing the schema, but the instance of the database will keep changing. So that is the difference. So we talk about a database schema and a database instance. Another thing with the relational database is that the rows out here, so I showed there were like these 3 rows. The ordering of the rows does not matter. So row ordering is not important. So there is no tuple or row ordering, but the column ordering matters. So that will matter. So if you're wondering why is this even, why am I mentioning it? You will see that will make a difference when you start writing queries. That you, for example, let's say I'm grading your output. I can't grade your output based on the fact that the ordering of your query is not, matching the ordering of the test query. So you're not looking at row ordering, but the column ordering, again, when I say it matters, I'll give you an example why I meant by that. So if you go back to, so remember this, when I said you load the database with initial values and then you insert into student values. So these values, which I've inserted, they have to match with the way you have created the table. If they do not match, you would have an error. Or when you're inserting into student, you'll have to say okay, Smith, and that's name, 17 is the SID. So either you have to say that, or if you don't say anything, it has to match up with this. So that's why I said that the column ordering does matter. So let me just go back. Then another thing about the databases is that you cannot have 2 rows that are identical. Each row has to be distinct. So So each row is really describing an object. So for example, in the student, it is describing a student. So each row has to be distinct. So even if every column in the two rows is identical, there has to be at least one column that's distinct. So so that is called the key. So if you go to the student, for example, the social security number could be the key. So a key is so this is important. It is the minimal set of attributes whose value is unique in each tuple. So what does it mean when so this minimal is important. That's why I underlined it also. And I do want to, because sometimes this is a confusing thing. So for example, in the student one, the social security number, might be the key. So you say that's a key. Or so, but if I so this is the key, but if I said, so I'll ask you, is social security number plus the address a key? And that is not a key. Social security number plus address is not a key. And the reason that even though it's unique, because social security number is unique, but social security number plus address is not a key because it's not minimal. So that's what I meant by saying that it has to be a minimal set of attributes. Or maybe sometimes let's say that if I said that you cannot have two students with identical names, so let's say last name and first name. So sometimes you will have alternate keys. So I might say that last name plus middle initial plus first name. I could say that that's also a key. Oh, sorry. So maybe a table can have multiple keys. So you can have multiple keys in the table. So I just want to ask this question. I did say a minimal set of attributes whose value is unique. So why is last name? So let's say we have a table. So instead of name, I have last name plus name plus middle initial. Why is last name plus middle initial and first name also a key? Like it's not, because sometimes people think when they say minimal, they mean that it means that social security number is only one column, while last name plus middle name plus first name is 3 columns. So why is that a key? That doesn't look minimal, right? So can anyone see the, I don't know if you understand the question that I'm talking about, is that it doesn't seem minimal. So what do I mean by minimal? I just want to clarify that.
Do you mean that the value that you're using for the key is like only the I guess most minimal or the most restrictive attribute in the key is the only thing in the key itself, if that makes sense? So in a social security number by itself can be the key, but if you try to use the social security number plus the address is only extra, where the social security number is by itself already unique.
Yes, you're right. Social security number by itself is unique, but when you add address, it's just extra. But last name plus first name plus middle initial, if you remove anything out of it, so I might, if I say that, okay, I'll remove the middle initial out of it, then maybe it won't be unique. So last name plus first name plus middle initial, all 3 I need together, it's unique. So that's what I meant by minimal, because I've noticed before that sometimes people get confused by the minimal. They think that because I use last name plus middle initial plus first name is not a key because it's got 3 columns. but it's the minimals, all three together form a key. So that's fine. But if I added last name plus first name plus middle initial plus address, then it's not the key. Or let's say I removed the middle initial. If I remove the middle initial from it, maybe it won't be a key anymore, because I might have a name like John Smith with the middle initial John A. Smith, and I might have John B. Smith. So it is a key because I have John A. Smith and John B. Smith is unique. But if I removed, let's say, middle initial out and I said, you know what, I'm just going to say last name plus first name, but then it's not unique. So I just wanted to clarify that you can, a minimal does not mean that a key can only have one attribute. It can have multiple attributes. So a table may have multiple keys. So the multiple keys, when you have multiple keys, they're all called candidate keys. So one of the candidate keys, so even though you have multiple keys, so maybe your student table has two keys, social security number and last name, first name, and middle initial. But even though you have multiple keys, you have to, for relational databases, one of the candidate keys has to be selected as a primary key. So that, let me write. Okay, so this is entirely by the designer, the database designer's choice. So it is not that one key is superior to the other key. It's something that database designers choose. And usually, so for example, even though last name, first name, and middle initial is unique, the inconvenience of having three columns as a key versus you can have social security number, which is a single attribute. It's more convenient to have social security number. So for example, on say my courses, where we have all student grades and all, the key is really the student ID number because it's a single attribute. But when I, for example, as a faculty, sometimes I have to look at my advisees on WebCat or on my Wildcat Success. I'm looking at the GP or some details about the student. I do not remember their ID. So I would type in their first name and last name, sometimes not the middle initial, but their first name and last name, and I can still retrieve all the elements. But on the back end, so there are two keys, but it's a better design to have the primary key to be a single attribute, if that's possible. And then, yeah, I guess it's almost time anyway. So are there any questions? And, so in this lecture, I have put out a lot of notation, terminology, candidate keys, primary keys, attributes, DDL, DML. So, so I mean, so all of this, I mean, it might seem a bit confusing right now, but I can, within a week or so, all of that will kind of stick in your brain. So, yeah, and then I'm just one moment, I'm going to try to